Okay, here we are back again looking at circles just a little bit more. So this first slide is just a review basically of what we did last time. So let's just make sure that we remember how to find inscribed angles and arc measures and things like that. So on question number 1, it asks us to find the measure of arc BC. Okay, well that is this arc over here. Okay, well, some things that we know, okay, I keep saying this, but things that we know that we have learned previously is that, first of all, here's a diameter. So I know that this is 180 degrees. So that's good to know. I know that this is an inscribed angle, and my inscribed angle, if it is 30 degrees, then the intercepted arc is twice that. So I know that this is 60 degrees. And I also know that all the way around my circle is 360 degrees. So I know that 180 plus 60 plus, we'll call that x, has to equal 360 degrees. So if we combine our like terms and subtract it from both sides, we would get that x equals 120 degrees. Okay. So let's take a look. We want to know what angle P is, so we want to know the measure of this angle. Okay, I don't have a diameter or anything like that, but I do know that I have a 77 degree angle and I have a 135 degree angle. And I know that if I find the measure of this arc right here, that completes the circle. So I know that 77 plus 135, and again I'm just going to call that x, plus x is 360. So I can figure out that x equals 148. Well, I know that my red angle is an inscribed angle, so if x is 148, angle P is going to be half that. So angle P is going to be 148 divided by 2, which is going to be 74 degrees. Okay, moving on here, it wants to know the measure of arc EH, which is from here to here. Okay, so what are some things that we can figure out from the information on the picture? Well, I do know that this angle here is 50 degrees, which means the arc that it intercepts, this guy right here, is 100 degrees because it's double. I also know that this angle right here is 42 degrees, which means this is going to be 84, which means, really, let's be honest, I just included that 100-degree information as something that we know, but we really didn't need to know what it was because EH is going to be 84 degrees. Okay, so what we're going to look at today is how lines intersect with circles, and there are 3 ways that they can intersect. The first way is on the circle, which that's one of the ways we've already talked about, because if you have 2 lines that intersect, let's just draw 2 lines here, on the circle, they meet here, basically what you have created is an inscribed angle. Okay, so we already know a little bit about what happens when one of the situations where they meet on the circle. So if we have it where it looks like that, that's just an inscribed angle. However, oops, not angel, angle. However, you could also have something like this where you have a line going through the inside, and then you also have a tangent line and they meet on the circle. So if we focus just on those 2 red lines, we have 2 angles that are created. We have this small angle right here that we'll call angle 1. And then we have this other angle here. They're like vertical angles, it looks like. But if we continue the blue and the green there, we're going to call this angle 2. So we're going to look at today at what happens with those angle relationships when we have something that looks like that, where you have a tangent line, here's your tangent line, and a secant that go through and create those 2 angles. We'll look at that first. And then another way that they could intersect is if you have 2 lines and they intersect inside the circle, not necessarily at the center of the circle or anything like that, but anywhere inside the circle. And what we're going to look at is what happens and what's the relationship with these arcs here that they intercept. Okay, and then the third way that we are going to look at how lines can intersect with circles is we are going to look at when they're both tangent, where they both look like that. Okay, looks like that was supposed to hit the circle. Okay, and what we're focusing on today is the measures of the arcs that they create. Okay, so again, we're focusing on when we have these lines that intersect, we're not looking at the angle measures, we're focusing on the arcs that they actually create. Okay, so let's take a look. We're going to go one by one. So the first thing we're going to look at is when they meet on the circle, and since we've already talked about what an inscribed angle is, we're going to look at what it means if you have a tangent line and a secant that go through. So we're going to look at this scenario first. This one's going to be the second examples that we look at, and then those are going to be the third examples. Okay, so if you have a tangent and an intersected chord, okay, I think I might have called it a, did I call it a secant on the other slide? But if you have a tangent and it intersects on the circle with either a secant or a chord, you're looking at just the part. Here's your inside of the circle, and then you have your tangent line. Okay, so if a tangent and a chord intersect at a point on the circle, the measure of each angle formed is 1/2 the measure of its intercepted arc, which is basically the same idea that we just did with inscribed angles, but now you have these angles where it's not two lines, both of them being on the inside of the circle. You have the tangent line on the outside. So essentially, if we look at this diagram up here, so we have angle 1, here's angle 1. Oops, I wanted to have, here's angle 1, okay, and it intercepts this red arc. So angle 1 is going to be 1/2 of the measure of that red arc. And similarly, we would have the other angle here would be angle 2, and it intercepts this arc. And that is all, angle 2 is going to be 1/2 the measure of that blue arc that I just drew in there. Okay, so let's kind of just take look at a couple examples of that. Okay, so if I have a 130-degree angle out here, and I am looking at this angle here, okay, that tells me angle 1 is going to be 1/2 the measure of its intercepted arc. So it's going to be 130 degrees divided by 2, which is going to be 65 degrees. Okay, so going the other way, all right, if this is 125 degrees, we know that the arc that it intercepts, this red arc, is going to be double. Same idea as we had with the inscribed angles, which means that red arc is going to be 250 degrees. Okay, why don't you go ahead, pause the video for just a quick second, try a couple of examples here on your own, and then come back and check to see if you are correct. Okay, that first one, we have an angle 1. Here's our angle. Here is our intercepted arc. It's 210 degrees, which means we would have 210 divided by 2, which would be 105. The measure of arc RST. Notice that RT is not a diameter. It does not necessarily go through the center of the circle. If it did, then that would be a 90-degree angle anyway. But you have the measure of arc RST is going to be double the measure of the angle, which is going to be 196. And then on the last one here, here's our angle. That's 80 degrees. It's asking about XY, which is going to be here. So that's going to be 80 times 2, which is 160 degrees. Okay. So now we're going to look at that second example. That second example back in our pictures that we drew was when they meet on the inside of the circle. So if you notice, we have two lines or chords that meet on the inside of the circle. And again, that creates these chords, okay? So we have the blue chord and the red chord. And there's again going to be a relationship. So if two chords intersect inside a circle, then the measure of each angle is half the sum of the intercepted arcs. Okay, so angle 1, okay, here's angle 1. Measure angle 1 is half the sum. So you're averaging the arcs that it intercepts because it intercepts 2. So it's going to intercept this arc, DC, and AB. Okay, so you're going to add those two together and divide by 2. Rather than multiplying by half, I always think add them together and divide by 2. You're just averaging them. And then angle 2, this angle, it's going to intercept with this arc and this arc. So we are going to add those two together and divide by 2. So again, let's basically, in my own little words here, if two chords intersect inside the circle, then you average the two intercepted arcs. Add them together and divide by 2. Let's look at some examples. Okay, so let's look at a couple of examples here. First of all, anytime we do these, we always want to think, where do my lines intersect? So that way I know what I need to actually do. They meet on the inside, but they don't meet on the circle anywhere. They don't meet at the center of the circle necessarily. So we're not going to have an inscribed angle. We're not going to have a central angle. So I have these two chords that meet like this. Okay. And you have angle X that intercepts this arc. So the two chords intercept that arc, and they also intercept this arc. Okay, and so what we do is if they meet on the inside, that means we are going to average the two intercepted arcs. So X is going to equal, I'm going to add 130 plus 156 and divide by 2, and I would get 143. The formula itself actually says 1/2 times. So if you're using the formula on the other page, it would look like that. I prefer that way of thinking about it, but that's just because I don't like fractions as well. I would rather divide by 2 than multiply by 1/2, which is ultimately the same thing. Okay, so let's take a look here at what we have. We've got two chords that are, let's just focus in on the chord part here, that are intersecting here and here. Okay, let me erase this little guy out here because we want to focus in just on the inside of the circle and the arcs that are intercepted. Okay, so I know that the measure of the angle on the inside here, this angle, which I could call, I guess I could call it X, but the measure of this angle right here is going to be the average of those two. Okay, well, how can I actually use the information that's given to figure that out? Well, what I do know is that this, oops, let me use a color you can see, this is a straight line, so I know that if this part of it is 102, I know that that missing part, which I had a little red dot there, is going to be, okay, hang on, let me get rid of that little red dot there, is going to be 78 degrees. So I know that that angle that is created with those two chords, okay, is going to be 78 degrees, and I know that 78 is the average of the two arcs that it intersects. So I would have y plus 95 divided by 2 is going to be 78. So to solve that, we're going to multiply both sides by 2. And 78 times 2 is 156. And then if I subtract 95 from both sides, I should get that y equals 61. So again, you cannot just assume that the information that's given is the only information you'll need to solve the problem. Sometimes you need to look at it, say, all right, which pieces of information are given to me and what do I need to use prior knowledge to figure out in order to help me solve the problem. Okay, so then the last thing, so we've talked about when they meet on the circle, then we talked about what you do when they meet inside the circle, and then the last thing is when they meet outside of the circle. Okay, so basically if it meets on the outside, so you're gonna have a point somewhere out here, and notice we're talking about angle measures and arc measures and things like that. We talked about in the last class or two, we've talked about like the lengths of these segments. If they meet out here, we've talked about that they're equal to each other. But right now we are focusing on the arc measures and the angle measures, not the side lengths. Okay, so basically if you have, I'm just going to zone in here on one, where they meet on the outside. Okay, so you have these two lines that meet on the outside. They could be secants, they could be tangents, but they should meet on the outside. You have an angle that is created out here, and the two arcs that are intercepted. And if you are going to find the measure of that angle, you are not going to average by adding the two arcs together. You're going to subtract the two arcs and divide by 2. Okay, and it's the same thing whether it's a secant and a tangent, or two tangents, or two secants, however it happens to be. You're going to find the two arcs that they intercept, subtract them, and then divide by 2. Okay, so I've kind of put that in simple words here. If two lines meet on the outside, subtract the values of the arcs and divide by 2. Okay, so let's take a look at this first one. Here's my 2. I've got oops, I wanted to use a line there. Here are my 2 lines. I've got this one and that one, and it creates this angle X out here. And the two arcs that it intercepts are 76 degrees and 178 degrees. Okay, so we know that if we are finding the measure of that angle, X is going to be, I'm going to subtract the angles, and obviously I'm going to subtract the bigger angle minus the smaller angle and divide by 2. Okay, so if I need to actually go ahead and solve that, I would need to say 178 minus 76 is 102. Divided by 2 is going to be 51. Okay, so let's look at another example here. Just a slightly different way to think about it. In this case, I have my angle. Here's my angle is 30 degrees right here. The two arcs that are intercepted, one is 44 and one is our missing value. Okay, and so I know my angle, which is 30 degrees. I'm going to subtract my bigger arc minus my smaller arc and divide by 2. So now, in this case, I know that I need to solve that. I need to multiply both sides by 2, and I get 60 equals A minus 44. If I add 44 to both sides, I get my arc measure is 104 degrees. So this arc right here is 104 degrees. Okay, there's just a couple of more of examples here. So why don't you take a second, pause the video, try them on your own, and then come back and listen to make sure that you've done them correctly. Okay, so let's go ahead and finish this one up. I know now this one makes you think just a little bit harder. Here's my angle X on the outside. I know they meet on the outside, so I'm going to subtract the intercepted arcs and divide by 2. Okay, well, all I know is that this central angle is 135 degrees. Well, if the central angle is 135 degrees, that means that my intercepted arc is also 135 degrees. But I have to think about, all right, how can I figure out what my other intercepted arc is? Well, going back to what we know and what we learned previously is all the way around the circle is 360 degrees. So I know that this arc, AB, on the outside here, is going to be 360 minus 135. So I know that this arc on the outside is 225. And using what we learned, I know that my angle, X, whatever this angle is. I'm going to subtract my big arc minus my smaller arc and divide by 2. So if I take 225 minus 135 and divide by 2, I get my angle out there is 45 degrees. Okay, and our last example here, okay, we have an angle on the outside that's 30 degrees. Here's an intercepted arc here. That's one of them that's intercepted, and then the other arc is this guy right here. Okay, well, it doesn't tell us anything about the red arc or the blue arc, so we're going to have to use some information that we know. Okay, well, I know that if this inscribed angle right here is x, then I know the arc that it intercepts is 2x. Okay, that's something that we learned previously. And then I also know that that blue arc completes the circle, which means the blue arc is going to be 360 minus 2x. Because if you think about it, let's pretend for a second that that red arc was 100 degrees. Well, the rest of the way around the circle would be 360 minus 100. So it's going to be the same idea. Okay, so now I know that my angle that is out here, 30 degrees, is equal to, I need to subtract my angle out here, so I have 300, or not, excuse me, I need to subtract my larger arc, so that would be the blue one, which is 360 minus 2x, and I'm going to subtract my smaller arc, the red one, which is 2x, and divide by 2. Okay, so we have 30 equals 360. I put my like terms together here, minus 4x divided by 2. Okay, don't worry about the minus 4x in there with a negative. We'll get that taken care of. So I'm going to multiply both sides by 2, which means I get 60 equals 360 minus 4x. If I subtract 360 from both sides, I get negative 300 equals negative 4x. Don't lose track of all your negatives here. And if I divide by negative 4, I get that x equals let's see here, 75. So what we have is a 75-degree angle here, which means this would be 150 degrees, which then also means if we wanted to ask, we could also figure out that the measure of the blue one would be 210. But again, you have to use that information that you know from previous lessons. You can't just assume that the two pieces of information that are given to you are the ones that are going to go in the formula. You really have to look at the diagram and think about it. And just like usual, we have a class kick for you to work on. So go ahead and get working on that and let me know if you have any questions.